All right. Okay, so we're going to learn about solving equations with variables on both sides. We're going to talk about also special solutions, like situations where there's no solution or infinitely many solutions, where there's not just one solution to an equation. And then we're going to use some linear equations to solve real life problems. Okay, so to solve an equation with variables on both sides, first, simplify if you can. So simplify both sides, meaning like one side at a time. Look at the left side, see if there's any like combined like terms or distributive property to do. Then look at the right side, see if there's any distributive property or combining like terms you can do. Then when you have a variable on both sides, you're going to use inverse operations to collect the variable terms on one side. So you're going to get all the variables on one side of the equal sign, and then you're going to get basically all the numbers on the other side, and then you start isolating the variable with more inverse operations. So we're going to use, just like before, we were simplify the left side if we could, simplify the right side if we could. And so the only new thing is we're going to use, if we have x on showing up on both sides of the equal sign, we use inverse operations to get the variables off of one side. So let me write that, because that's maybe an easier way to understand it. So first, you simplify each side of the equal sign if you can. Then you'll use inverse operations to get the variables off one side of your equation. And then it's back to normal. You're just going to keep using inverse operations to get the variable by itself. So when we're simplifying this, we don't do both sides of the equation at the same time, right? We simplify, we simplify the left using distributive property or combining like terms. We simplify the right using distributive property or combining like terms. Then the rest of the stuff, we use inverse operations. That means we're going to do the same thing to both sides of the equal sign at the same time. Okay, so here's our first example. We've got, you can see that we have a variable on both sides of the equal sign. So the first thing we check is to see if we can simplify on either the left side or the right side. So on the left side, we've just got 10 minus 4x. So I have two terms. One of them is a constant, the 10. One of them has a variable. So these are not like terms. I can't combine them, so I can't simplify that at all. The right side is just one term. You can't simplify that. So there's no simplifying that we can do on either side. So the next is we want to use inverse operations to get variables off of one side. Technically, it doesn't matter which side you get it off of, but you can there's situations where you can see one side might be better than the other. If I was to say, I want to, like for this situation, I would probably want to get rid of the negative 4x off of that side, because if I was to get rid of the negative 9x, then it would just be equals 0, and I would have everything would be on one side of the equation. So it would be your goal is to end up with a variable on one side and just a number on the other side. So you kind of set yourself up to do more work if you get rid of the negative 9x, when it would probably be less work to get rid of the minus 4x, and then you would just have the 10 over here alone on that side. So how are we going to get rid of the minus 4x? We're going to use inverse operations. So this is 10 minus 4x. What's the opposite of subtracting 4x? Adding 4x. So if I add 4x to both sides of the equal sign, the 10 minus 4x plus 4x takes you right back to 10. And then negative 9x plus 4x is negative 5x. Yeah. The 10, oh, just because it was right here, it started off as 10 minus 4x, right? So imagine we don't know how much 4x is yet, right? But if I had to think about it like dollars, sometimes that makes it easier. If you got 10 bucks and then you lose 4x, but then you get it back, you got 10 bucks back, right? So the 10 minus 4x plus 4x, these guys are inverse, so they undo each other. Exactly. And then because of the addition property of equality, we canceled it out by adding 4x, right? So in order for the equal sign to stay true, we have to do it once on each side, right? Because we just introduced that plus 4x out of nowhere. But we knew it would cancel that out. That's why we did it. But we have to do it on both sides. Okay, so now our variable only has one operation left happening to it. X is being multiplied by negative 5. So the inverse of multiplying is division. So we're going to divide both sides by negative 5. Negative 5 divided by negative 5 is 1, right? That's why they're inverse operations. So you just have x left on this side. And then 10 divided by negative 5. Positive divided by negative will be negative. And 10 divided by 5 is 2. So this is negative 2. So x equals negative 2. And we can check it by plugging a negative 2 in for x. I'll do it on the first one, but maybe not on the others. So here's where we're going to check over here. 10 minus 4x equals negative 9x. And then we're going to plug in a negative 2 and see if that works. Okay, so 10 minus 4 times negative 2, that's going to become 10. Now we're doing negative 4 times negative 2, so that becomes positive 8. And then on the other side, negative 9 times negative 2 is positive 18. And 10 plus 8 equals 18, so we are happy. Okay, this one looks fun, right? So the first step is always to try to simplify one side at a time if you can. This one definitely has stuff we can simplify, right? We've got get rid of that just because that kind of, I wish that they put a little more space in between them. So we can distribute this 3 through those parentheses, and we can distribute this 1/4 through these parentheses. So we're going to simplify both sides right now. So on the left side, 3 times 3x is 9x. 3 times negative 4 is negative 12. Now, here's the part you love, fractions. 1/4 times 32. Multiplying by 1/4 is the same as dividing by 4. So it might be easier to think of it 32 divided by 4. 32 divided by 4 is 8. So this will be, so when we do 1/4 times 32x, that gives us 8x. And then, let's see, does 4 go into 56? 4 times what? 14? Now that doesn't always work out like that. They set up this problem to where when we distribute the 1/4, it came out evenly. That doesn't always work though, right? And sometimes a trick that you were taught is to multiply. You could multiply both sides of the equation by 4 to clear the fraction, but we didn't really need to do that on this one. But now we have, so we had to simplify first, and now we realize that we have x on both sides. Well, we could have realized we had x on both sides at the beginning, but the x's were locked up inside these grouping symbols, so we had to distribute and simplify first. So now we see that we've got x on both sides of the equation. So we need to use inverse operations to get it off one side. Generally, when I'm trying to decide which one to get it off of, I want to try to, it's easier if I end up with a positive number in front of x. So I generally try to get rid of them off the side where there's a lower number. So 8x is 8 is less than 9. So I want to get rid of the 8x off of the right side. This is a positive 8x being added to 14. So to get rid of a positive 8x, we would need to subtract 8x from both sides. So subtracting 8x once on the right side of the equal sign, subtracting 8x once on the left side of the equal sign. So 8x minus 8x is 0. So on the right side, we just have 14. And on the left side, 9x and 8x, or 9x minus 8x is just x. And then we still have the minus 12 right there. And now the only thing that's happening to x is subtraction. So the inverse of subtraction is addition. So we are going to add 12 to both sides because we want to get rid of the minus 12. And we get x equals 26. Okie dokie. So now we're going to look at some of those special situations. So I wrote a couple of simple equations up here that when we try to solve them, we're going to get weird stuff happening. So this first one, x plus 3 equals x plus 3. We see we got x on both sides. So our instinct is to be like, well, we just learned that you have to use inverse operations to get it off one side, right? So if I say I can get it off of this side by doing minus x, right? So if I do minus x from both sides, what ends up happening? X minus x is 0 both times. So we just get 3 equals 3. So what does that mean? It kind of means that x could have been anything, right? X could have been anything we wanted, and then it would have been okay. If x was 9, right, then it would be 9 plus 3 equals 9 plus 3. 12 equals 12. No matter what number you pick for x, this equation will always be true. I can't always spell correctly, though. Always true. We call this an identity. We call this type of equation an identity because the left side is exactly the same as the right side, no matter what, and it's always true. And in this situation, we call it an identity, and we say it has infinitely many solutions. And the reason we say that is because you can pick any number for x, and it works. So an identity, if you're solving an equation, so here's what will happen. You won't always start with an equation that looks this simple, right? Where you can tell that the left side is exactly the same as the right side. But as you're working through solving, you might get to a point that looks like this. If you ever get to a point where the left side is exactly the same as the right side, you can stop and say this is an identity and it has infinitely many solutions. Sometimes you won't notice it right away, but you'll go to subtract x's off of one side and all your variables will cancel out. Right? And so when all your variables cancels out, it depends on what you're left with. If you're left with 3 = 3, that means it's always true that x can be anything and you have infinitely many solutions. But what about over here with this one with the y's? If you try to take, you got y on both sides, we need to get it off one side. So say we're going to subtract y. We have to subtract y from both sides of the equal sign. And what do we end up with? We end up with the y minus y is 0 on both sides. So we end up with -4 = 9. Right? So we end up with something that is never true or something that's just straight up false, right? So in this situation, if you're going through and solving for a variable and all your variables cancel out and you end up with an equation that's false, that means there's no solution. There's no number we could pick for y that would make this work. So as you're solving through, sometimes all your variables will cancel out. If what's left over is true, like sometimes it'll be 0 = 0, but that's true also, right? As long as it's the same number on both sides, that's an identity and it has infinitely many solutions. If all your variables cancel out and you end up with an equation that's false, that means there's no solution to that equation. So let's look at a couple of these examples. Like looking at these, you can't really tell right away if there's no solution or infinitely many solutions. So you have to kind of start solving. So we'll start by simplifying the left side over here. We're going to distribute the 3. So 3 times 5x is 15x. 3 times 2 is 6. And you can kind of start to see what direction it's going in now. We've got x on both sides. I can do minus 15x to get it off of one side. But that means I have to do minus 15x to both sides of the equal sign. And then what do we end up with? On both sides, 15x minus 15x is 0. So on the left side, 0 plus 6 is 6. And on the right side, 15x minus 15x is 0. My trash can's blowing away. Okay, so we end up with 6 = 0. That is false, right? So this equation has it's right on the corner of the laptop cart, the pink thing, corner closest to me. So this equation has no solution. So then B, let's simplify the left side. We have distributive property to do over here. Negative 2 needs to get distributed through those parentheses. So negative 2 times 4y would give us negative 8y. And then negative 2 times positive 1 would give us negative 2. And we can see right now the left side is exactly the same as the right side. So this is an identity. And it has infinitely many solutions. And depending on where you see a test, like you're going to take tests, SATs and all that stuff, some places will say in which one, it might be multiple choice. Which one is an identity? Which one has infinitely many solutions? So that's why I tell you both of these. It's called an identity and it has infinitely many solutions. Okay, so here's like a summary of solving linear equations. First, you're going to use the distributive property if there's any grouping symbols, right? Then simplify the expression on each side of the equation. So left side, see if you can combine like terms. Right side, see if you can combine like terms. Then step 3 is to get the variable terms on one side and the constant terms on the other side using inverse operations. Step 4 is to isolate the variable using inverse operations. And whenever you do inverse operations, that's when you do it to both sides. The top 2 steps are one side at a time. Because using the distributive, if you use the distributive property on the left side, you haven't changed the value, so you don't have to do anything to the right side. If you just combine like terms on the left side, you're not changing the value of the left side, so you don't have to do anything to the right side. But if you use an inverse operation on the left side, say subtract 4x from both sides, you have to do that to both sides to keep the equation equal. And when you're doing homework, check your solution. Could be checking the answers to see if you did it right? Check to see that you got the right answer. Because I'm always going to give you the answers on an assignment that I give you. If it's a homework assignment or a practice assignment, I have to give you the answers because it doesn't make any sense to not give you the answers because it doesn't make any sense for you to do a problem and then not know if you did it right. That's like if your basketball coach made you practice basketball with a blindfold on. Like if you don't know the ball's going in, you don't even really know where the target is. You're just shooting. It doesn't make sense. So every time you do a problem, you have to check the answer to see if you did it right. The only time I'm not going to give you the answers is like on a quiz or a test. And so I hope that what you learned from that is that algebra is not just about getting the right answer. It's about knowing the process. It's all about the process. Inside of algebra, it's all about the process. Outside of algebra, it's all about the Benjamins. Okay, so we got one last example that's going to go over using linear equations, solving a linear equation that has to do with real life applications. So a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, I usually need a picture to help me understand. So I'm gonna draw. Here's my river. There's lots of water in here. This is the river. Then here's our boat. Okay, so it travels upstream for 4 hours. So it's going to go this way. And that took 4 hours. Then turns around and comes back. And that only takes 2.8 hours. So we're going to have to use, they tell us about time. They tell us about speed, right? 3 miles per hour faster. And they're asking about a distance. So we have this equation, distance equals rate times time. And going upstream, they went a certain distance, right? And then when they came back, they went the exact same distance, right? So the distance that they traveled is the same in both directions. So that means that the rate times the time for the trip there has to equal the rate times the time on the way back because the distances are equal. So the rate times the time on the trip there has to equal the rate times the time of the trip back because the distances are the same. Okay, I know the time there and the time back, right? The time there was 4 hours. Or I'll wait until I know that. Okay, so I know that T1 is 4 hours. T2 is 2.8 hours. And then what do I know about their rates? I know that however fast he was going when he went on the way there, he was going 3 miles an hour faster on the way back. So that means that the rate on the way back, R2, is 3 more than his rate on the way there, right? So R2 is equal to R1 plus 3 miles an hour, right? Whatever rate 1 was, add 3 miles an hour to it, and that's your rate coming home. So how does that help us? It helps us because now I can substitute in for everything except for R1, and I can solve for the rate on the way there. So R1 is going to stay R1, but T1 is 4 hours. So R1 times 4. R2 is, we're going to just write R1 plus 3 instead of R2, because that's what it equals, right? R2 equals R1 plus 3. So instead of R2, we're going to write R1 plus 3. And then we have to put parentheses around that because that rate gets multiplied by the time to, which was T2 is 2.8 hours. All right, so now we've got this equation, and we're gonna use some of our skills that we just learned, right? We got to distribute, we got parentheses here, we have to distribute the 2.8. And I can rewrite this. This is just 4R1. Okay, so on the left side, we get 4R1 equals, and then we're going to distribute here. 2.8 times R1 is just 2.8 R1 plus 3 times 2.8 is 8.4. So then I've got my variable on both sides. So I need to use an inverse operation to get it off one side. Since I already just have a number, 8.4 over here, I want to get rid of the 2.8R one. So that's a positive 2.8, and it's added to the 8.4. So I need to subtract 2.8R from each side. So 4 minus 2.8 would be 1.2. And that equals 8.4. So to get the rate on the way there, we just need to divide both sides by 1.2. .4 divided by 1.2 is 7. So we get R1 is 7. Okay, so now how does that help us? We wanted to know how far did the boat go upstream, right? Well, we can use D equals R times T to figure that out now, because we know the rate that he was going as he was going upstream, and we know how long it took him to go. So the distance equals the rate times the time. So we're going to use rate 1 and time 1 to get how far he went. So rate 1 is 7. Time 1 is 4. So the distance was 28. And the rate was in miles per hour. And that was 4 was in hours. So this is miles. It should be the same if we do rate 2 times time 2, shouldn't it? Because it's the same distance. So I just want to show you, you don't have to do this, but I just want to show you that you could have done that too. What rate 2, though, is 3 more, right? So 7 plus 3 is 10. So you're going 10 miles an hour on the way back. And it took 2.8 hours. So that would also give you 28 miles. So the distance was 28 miles. Notice how I circled 28 miles and not D equals 28. D equals 28 is the answer, is the solution to that equation, but it doesn't answer the question that they asked. How far does the boat travel upstream? The answer is 28 miles. Okay, that's the end of that lesson.